Welcome to Rges Algebra 2. We're going to focus, this is lesson 28A, and we'll focus on sections 8.7 and 8.8. Before we begin, I'd like to encourage your hearts with this wonderful passage from Isaiah. It says, "In returning and rest shall be your salvation." So we are definitely in a season of rest as everyone is hunkered down and pretty much no social contact, and so we are returning in this time. We have a choice. Basically, we have a choice what we can do with this time. We can chafe against it and be aggravated in our spirits and frustrated. We can be fearful and anxious, which of course there is some anxiety in this time because it's stressful. Physically for people, it's stressful emotionally, stressful economically for many people. So there's certainly a time of stress, but in that time, let us return to the Lord, call upon Him, be grateful to Him, cultivate gratitude, thankfulness in the middle of this, and lean into Him, who is our strength and our provider, and the one who's always eager to help those who call upon His name. So in returning and rest shall be your salvation. So I want to encourage you, exhort you to use this time and focus yourself in this time. And it can be a blessing even in the midst of stress. Sometimes stress pushes us to grow and to pay attention to things which we have not paid attention to as much as we could or should have for a while. So that's my exhortation. Take that to your heart. I'm going to be giving you answers to section 8.6 before we begin our new ideas. So make sure that you have your homework and you have it in hand so we can go over answers together. Now, as always, when we go over answers, if you have not been able to merge your answers with the proper answers when you try them again and you still have confusion, I would encourage you to text me. Text me at 505-301-1357 and just tell me the name of say Algebra 2, the name of the course, say the section number, for instance 8.6, and say the problem numbers that you still are struggling with, and I will be sure to address those in the next tape. So I encourage you to do that, something like this, okay? All right, now go ahead then and let me give you the answers, the problems that you were assigned. This is 8.6, and the problems you were assigned were 1 through 22 all, as well as our word problems 32 and 33. I will not show you how to work them all, but I will go over all the answers and giving you a few examples on how to work them as we go along. Number 1, 10 times the square root of 2. Number 2, 10 times the square root of 3. Number 3, 10 times the square root of 3. Number 4, 5 times the cubed root of 4. And number 5, 5 times the cubed root of 5. I'm going to do one for you. Let's see, I think I've done 1, 3, and 5 on a previous tape, so I'll do number 4. So here we illustrate how to do one of these. I would always simplify what's the radicand first, stating it as primes. Then I will do any division between the index and the exponent, as we illustrated in the first term here. And then do some simplification, also bringing out to outside of the radical. For instance, we're looking for groups of 3. I have 2 groups of 3 with 2 left over. That's what's indicated here. And then simplifying so I can express it and easily identify my common roots so that I can add them together. All right, so let's look at our answers now on 6 through 10. The answers would be 1/6 square root of 3. I could also write that as the square root of 3 over 6, either way. The cubed root of 2. This 2 times the cubed root of 3. Number 9. 1/2 times the square root of 6, or the square root of 6 over 2. And number 10, 5 times the cubed root of 4. Now let me go ahead and pick one of these to illustrate. Now when you are doing these problems on your own, you might combine more than one step together. I'm trying to illustrate them very carefully, showing every step so that if you are at all confused, it will be obvious how I'm doing this. Now let's continue on with some of our answers. Let's go with number 11. We have 8 times the square root of 2. Number 12, we have 10 times the square root of 3. Number 13, we have 6 times the cubed root of 2. And number 14, we have 7 times the square root of 5. Number 15, we have 2 times the cubed root of 5. And number 16, we have 6/5 times the cubed root of 25. Let's stop right there for a minute. I think I'll illustrate number 16 for you. Now the first step I will do is I will write my 8 and my 27 as an expression of something cubed. I hope you recognize, but by familiarity with what because we've been working with them a while, that's going to be the cubed root of 2 cubed and the 2 cubed root of 3 cubed. Let me go ahead and write that down. Next thing I notice is that all of these can be simplified, and so we'll do that. This first one, remember we're looking for groups of 3 to be able to pull it out from under the radical. And so the next idea then is that my denominator, remember I don't want a radical in the denominator. Well, how many more 2's, how many more 5's? Now notice they're all the cubed root of 5, so I'm going to have this answer for all 3. How many more 5's do I need to be able to pull it out? I've got 1. I need 5 to the cubed, or 2 more 5's to be able to pull it out. So if I multiplied each one of these by the cubed root of 5 squared, right, I would get the cubed root of 5 to the third, or 5 in the denominator. But if I do that, I need to multiply the numerator also by the cubed root of 5 squared, or the cubed root of 25. That is going to be true for all 3 of these terms. So let's do that, and I'll show you what we end up with. Okay, a couple of rules now to remember. We have the same denominator. We must always have the same denominator in order to add or subtract. So that's fine. And so now we can add or subtract these. We also can only add when the radicand, the index and the radicand are the same. So this fulfills that. So we can add those 3. And now all we have to do then is add 2 plus 1 more, okay, plus 3 more is 6, the cubed root of 25 all over 5. Or I could have written it 6/5, the cubed root of 25. Doesn't matter. They're the same idea. Okay, so that's how you do that. Now let's continue on with our last set of answers. Number 17 should be 38, the square root of 2. Number 18, 2/5, the cubed root of 10. Number 19, -2, the cubed root of 4. Number 20, in parentheses, let me write this on the next page. Okay, let me write this on the next page for number 20. These are the answers to the last 3 because they're a little harder to read orally without you possibly getting confused, especially 20 and 21. Now, let me pick one of those to illustrate here. Okay, I think I will, trying to think which might confuse you the most. Let's do number 20 together. Okay, so now that I've taken out outside the radical, those things that are squared and under the radical, I'm going to then do a little simplification. I'll distribute this. This becomes 3a minus 2 grouped together, the square root of 2 plus 9x, the square root of, well, that should not be the square root of x. That should be the square root of 2. Let's fix that real quick. Okay. They have the common index and radicand, so I can add these. And when I add them, I'll just simply group them all together. So it will look like 3a. Whoops, I didn't distribute correctly either. Boy, I'm making a lot of messes here. Sorry. Pay attention, Mrs. Kinzer. Okay, 3a minus 6 plus 9x. They can't be combined, technically, but I'm adding, like if I had a 2 here and a 3 here, I'm adding these two together, but because they're not like terms, they can't be combined. And then the square root of 2 is the radicand I'm combining. All right, so hopefully that looks really clear to you. Let's give you the answers now for the word problems. If 4 pounds of chicken and 2 pounds of ground beef cost $10.74 and 6 pounds of chicken and 1 pound of ground beef cost $12.13, what's the cost per pound of each? So I have chicken, that'll be my C, and beef, and that'll be my B, and I have 2 scenarios, so I'll have 2 equations. So for number 32, my equation should look like 4C plus 2b equals 1074, 6c plus 1b equals 1213, and then we simply want to combine these with a linear combination. I would tend to multiply this line by -2, so I'll have positive 2b in the top line and minus 2b in the next line. My b's will cancel out, and the rest is just arithmetic. I'm pretty sure you can work that out at this point. The chicken is going to be $1.69 a pound, and the beef is going to be $1.99 a pound. So hopefully with that little bit of instruction, if you couldn't work it out all on your own, you're able to work it out. Now number 33 then says 1 United States gold coin weighs 1/2 as much as another. If the combined weight of 3 of the smaller coins and 2 of the larger is exactly that much, what is the weight of each? So I have a smaller coin and a larger coin, and I'm going to have 2 equations. So this is what I would get. The smaller, it says 1 coin weighs half as much. Well, if it weighs half as much, it's got to be the smaller one. So S equals 1/2 L. And then it says 3 of the smaller plus 2 of the larger equals so many grams. So I would just simply do a substitution. Every time I see the S, I would substitute that, and I would do my arithmetic, and the smaller equals 16.965 grams, and the larger equals 33.92 grams. And so hopefully with this additional information, you will find that easy to do. Now let's go on then to our new concepts. Our new concepts will be found on 8.7, multiplication of radicals, and 8.8, division of radicals. Okay, the critical rule to multiply radicals is you must have the same index. Now, when we do have the same index, it's very straightforward. Let me show you. In this example, we're multiplying 2 radicals together. They have the same index. They're both square roots. So I can multiply them together. To do that, I multiply what's outside the radical together. 3 times 6 is 18. I put my square root sign, I multiply what's inside the radical together. 5 times 8. Or I could say 5 times, I would tend to want to express that as 2 to the third. Okay. Why would I want to do it that way? Well, because then, remember this is a square, so I can take 2 out, and I get 2 times 18, or 36, leaving 1 under. Let me do that in 2 steps, I'm sorry. Showing you a little clearer. Okay, so if I've got a square root, I've got 3 2's, and under the radical, I take out every grouping of 2, so 1 gets pulled forward, and 1 remains under. Okay, for every group of 2, remember 2 divided by 2, 2 divided into 3, I'm looking at this and this, okay? We have 1 going forward. So if I have 3 divided by 2, I get 1 remainder 1. That means 1 goes forward outside the radical and 1 stays under. 1 what? 1 of the root. The root is 2. Okay? So this is an old idea, but I want to illustrate that very carefully for you. So now just clean it up. 18 times 2 is 36, and clean up what's under, and that's my answer. So pretty straightforward. What you do is if you identify they have the same index, you multiply what's outside times what's outside, what's under times what's under, and clean it up to simplify it. Now what if they're not? That's the next idea. Okay, in this one I have a cubed root and a square root. So they're not the same. Well, do you remember how to make them the same? We've done that before. The first common one they would have would be the 6th root. Remember that? So I can convert these both to the 6th root. Copy my 5, make it look a little nicer. Okay, so to convert a cubed root to a 6th root, I'll need to square this, right? Because it's 3 times 2 is 6, so that'll become my new exponent here. Same way, 2 times 3 is 6, so I'll put a 3 cubed there. I think I'll just actually keep that written that way. If I can. Come on. Here we go. Let's try that again. Okay, so we're squaring that. And we need to cube this. Okay, and the reason why is it's really actually simpler, more simple, wow, to keep them in their exponent form so I can easily recognize my simplification. There we go. Okay, so divide both of these by 2, and we'll get 5, the cubed root of 2. And we're multiplying, recall. And we'll divide both of these, and we'll get this. Wait a minute. I am confusing myself a little. I'm going backwards here. Okay, probably a good idea. I was moving right back to here. So I didn't want to do that. I forgot what I was about here. I'm not to simplify at this stage. What I'm trying to do is multiply these. Okay, so they need the same index to multiply. And they need the same, well, that's all. They need the same index. So let's go ahead and simplify this and this. We'll get 5, the 6th root of 4, times, should have a 4 under there, 4 there. 4, the 6th root of 3 times 3 times 3 is 27. Okay, so what's the rule? We're multiplying, in order to multiply two terms that have radicals, they need to have the same index only, not the same radicand. They need the same index and radicand to add or subtract. So what do we need to do? Multiply what's on outside, the 6th root, multiply what's inside, that would be 87. plus 28, or 108. And that's how we do it. Let me show you two more here. All we need to do in order to multiply is have the same index. This is a square root and a square root. I'm fine. Multiply what's under together. You get the square root of 36, and the square root of 36 is 6. Very straightforward there. Let's go ahead and get something a little more complicated. Okay, so something like this, I notice that I want to multiply. I need the same index. I do not have the same index. I'm all about simplifying what I've already got before I do any conversions like that. I find those numbers easier to work with, so I'm going to rewrite my 250 as primes. That is 5 to the third times 2. Okay. And this is times the square root. I'll just write it in there so it's easier to see. All right, now I could pull this forward. And so I get 2 times 5 is 10, the cubed root of 2 times the square root of 2. Now, what do I need? I need a common index. So the common index will be 6. Whoop. Okay. I had to multiply by 2, so this would be 2 squared, or 4. I had to multiply this by 6, so this will be 2 to the 6th power. That would be 64. So this becomes 10 times 1 outside, 10, the 6th root. Well, I'm glad I'm showing you all the ways you can make mistakes here. This is already a 2. That's why I tend to write it in there. Okay, and I did not, and that caused me to err. Let me erase this 2 because I can't read it anyway. Okay, now, so I'm moving to the 6th power, so I need to have 2 cubed. There we go. Okay. Now, probably in this case, I should have also just left this as 2 squared, okay? Because that's going to be easier to multiply, actually. So this will be 10 times 1 on the outside. On the inside, the 6th root of 2 to the, what do we do when we're multiplying 2 to the squared times 2 cubed? What do I have to do to exponents to do that? Okay, I'm going to multiply, you're going to add exponents, right? Okay. So I can't pull one forward, and so all I have to do is simplify 2 to the 5th, which is 32. Kind of get a feel for these here. Let's do another one more here. And this would be number 12. No easy simplifying of each term first off, so we just need to, this remember is the square root. Okay, so we want this to be a 6th root, and this to be a 6th root. Okay, so I'm going to have to put x cubed, sorry, let me write a little more clearly here. X cubed, y cubed. Here, I'm going from a 3 to a 6, so I'm going to square. X squared squared would be x to the 4th. Right? Y squared squared would be y to the 4th. Multiplying, we get a 2 on the outside. What do we have underneath? What are we doing when we have x cubed times x to the 4th? We've got 7, we're adding, right? So this will be to the 6th power. Let me get it a little bigger here. X to the 7th, we're adding. Y to the 7th, I can pull out 6, so I get 2, right? every group of 6 can go out, so I'll get one x out, one y out, leaving me with one x under, one y under, and we're talking about the 6th power. There we go, or the 6th root. All right, so that's 3 of them. I think that's a good start. Let's go on to 8.8, division. Okay, so division is simply the inverse of multiplication, and so our rules on what we need will stay the same. Here we need the same index. So if this is my first example problem, I need a same index, but that's not what I have. I have a cubed root and a square root. So we're going to convert those to 6th roots. I'm probably going to go ahead and simplify this as I go. I tend to simplify as I go, so that'll be the same as 1/2. I don't need to write that one. Let's not, because I'll have something else there. So I'll put a 2 in my denominator. I'm going to look at a 6th root and a 6th root so that I can divide what's under the radical. Okay, or that I can even do any division here. Okay, so, well, I can divide what's outside. All right, now, let's do it then. The cubed root to the 6th root, I need to square. So this is the same as, well, I'll just square it. There we go. Okay, now, that's a 2. Make sure, yeah, that was poorly written 2. Okay, 2 to 6 is 3, so 2 cubed is 2 times 2 is 4 times 2 is 8, right? So what do? I've already done the division outside. Maybe I should have, to be maybe consistent with how I showed you before, we converted our indexes first, and then we, rather than multiply, we divide what's on the outside. We divide what's underneath. And that's the answer. Okay. Let's do another one. Okay, on this we'll make our common index, the 12. We'll have to raise, to go from 3 to 12 is to multiply by 4, so I have to raise this to the 4th power, meaning multiply to get 8. On the bottom, I have to, 4 times 3 is 12, raise it to the 3rd power. No simplification going on there. Okay, but I don't want a radical in the denominator, so I need one more step of simplification. And so I need how many more? I need y to the 9th. The 12th root of y to the 9th multiplied by both the numerator and the denominator. Okay, multiplying on the outside, or dividing on the outside, we don't get anything. Underneath, of course, we're going to now, on the outside we don't get anything, we're going to multiply underneath, so this becomes the 12th root of x to the 8th, y to the 9th, all over, we did this so we could pull the y out, all over y. And that's the answer. So I'll let you play with these and get your feet wet, and then we'll talk about any confusion next time. Let me give you your homework assignment. Okay, no new instructions, I don't think, for this. So go ahead and do this diligently, and I'll be posting more tapes Wednesday or Thursday morning to keep you caught up. Have a blessed day.